everyone, thanks for coming. Today I'm going to talk to you about how I applied 3D printing into developing cost-effective solutions for individuals with upper limb paralysis, specifically sports use. The injury that I looked at specifically were brachial plexus injuries, which is a bundle of nerves located in your neck that is responsible for the control and movement in your shoulder, arm and hand. Damage to these nerves can result in a life-changing injury whereby the individual becomes permanently or temporary paralysis of their arm. If we look at the current market, prosthetics versus orthotics, prosthetics look sort of designed to be bespoke and enable an individual to return to a sport. They're designed to mimic a limb. They're either known to be extortionately expensive, but in the current media you've probably seen sort of 3D printed prosthetics as sort of an up-and-coming sort of thing in the media. When you compare it to orthotic devices, they're very much clinical in appearance. They don't always enable the individual to regain arm use, so the limbs become immobilized. So you can see the sort of motocross cyclist there is forced to overcompensate with their unaffected arm, so they're left unbalanced. They're unable to regain bilateral arm use. So my project was looking into ways in which I could develop cost-effective products that enable these individuals to regain bilateral arm use while cycling. So this was the main area that I focused on. Sort of mountain biking and cycling are becoming more and more popular throughout the UK. And we have two comparisons here. We have an individual that uses a prosthetic device that enables him to return to mountain biking. And then we have an individual with a brachial plexus injury that is sort of trying to get back into downhill mountain biking with the use of one arm, which you can imagine makes them quite unbalanced and puts a lot of strain on the body. Dominic Egbeer, head of surgical and prosthetics at PDR, kindly introduced me to Tom Wheeler about sort of 13 weeks ago. He sustained a brachial plexus injury around 4 years ago, which left his right arm paralyzed. Tom was a very enthusiastic downhill mountain biker prior to his accident, and since then he has been developing cost-effective arm orthoses that enable him to regain bilateral arm use, which you can see him using here. Tom's arm brace consists of a shoulder strap. It's all made from carbon fiber, and the dampening effect is created through a cross-bracing gas strut and two hinges. It's bespoke to his arm shape, and he attaches his arm to the bike through this 3D printed PLA tray which slots onto the handlebars. This enables him to rest his hand on it, and it just works through a means of two ratchets either side that secures his arm to the bike, which you can see him using here. My brief was to develop sort of a 3D printable exoskeleton that enables individuals with these injuries to regain arm use. I was looking at ways to make them generic, working to small, medium and large sizes, reducing cost, looking at the usability aspect, so how I can make these products easy to put on through single-handed sort of adjustment and use. So I began looking at initial concepts. So obviously a physical effect of brachial plexus injuries that you get a lot of muscle wastage, so you get a reduction in arm circumference. So my project was looking at ways in which you could build in an element of adjustability into the arm brace. I didn't go straight into sort of 3D printing applications. I did some low fidelity models with materials that I had available to me. Once I had an idea in my head of what worked and what had the potential to work, I was able to carry these through into 3D CAD software, where I was able to develop flat panels that could be printed and molded through the use of FDM printing and PLA material. I had look at a variety of adjustment methods, from elastic to lacing, to see how you could adjust the upper panel of the arm brace. So here you can see this panel would sort of be like a clamshell that sort of goes around the top panel of your arm. This prototype sort of progresses on from that. It's been entirely 3D printed from PLA to a flexible NinjaFlex material. Building in a means of adjustment, like I said, enables the individual to account for muscle wastage and change in arm circumference sizes. And then a Velcro strap on the inside enables the individual to easily tighten the arm brace. I also wanted to address the ability for individuals to customize products to suit their individual needs and aspirations, sort of color preferences. So these lining materials can be just pulled away from the shell and interchanged to suit sort of individual tastes. My development went on, so the problem I found with the lacing system was that you get a lot of linear movement between the two panels. So when you have a force applied through the dampener, the panels move independently to one another, causing unwanted movement. So in response to this, I included 2 aluminium pins with sort of interlocking structure that prevents this, which you can see here. Tom's arm brace, which I referred to earlier in my presentation, used a cross-bracing dampener. The sort of features of this dampener is that it's supple. It provides a firm end to the stroke to stop the individual going over the handlebars of the bike. And it's responsive to account for uneven terrain that the individual might be cycling over. What I wanted to address was how you could make these more customizable and how you could incorporate the cross-bracing dampener into the hinge that you saw on the previous design. So the previous design had the hinge and a cross-bracing dampener. My design was looking at how you could integrate the dampener within the hinge. So this concept works off a cam. The top piece here with the 2 holes is fixed to the upper arm of the arm brace. These have all been SLA printed. And within the cylindrical chamber, there is a spring and a floating pin and a screw thread at the base, which allows the individual to adjust the spring strength and the preload of the spring depending on the severity of their injury and sort of the amount of support that they need from the dampener device. I went through a range of concepts using 3D printing and rapid prototyping techniques, and sort of the concept that came up on top was it worked off the principle of compressing air. So obviously the more you compress air, the firmer sort of effect you get, and through introducing a spring you get an effect that is not only had a firm end of the stroke, but it's responsive and reactive to the movements of the individual while cycling. And just adjusting the shape of the cam shape just meant that it didn't over-compress. I followed a similar process for the forearm design. So, like I said, I went from lacing through these to the rods. So you can see how the dampener begins to mount onto it. One vital element throughout my project was sort of gaining user insight into the sort of the development work that I was making. So Tom was kind enough to test out some of my prototypes, it was great to get feedback, no areas of difficulty that I was able to then go back to the drawing board and amend. So you can see sort of how the adjustment works around the circumference of the arm. The problem I had was that printing the panels flat at this stage in the project wasn't providing me with the accuracy. So obviously printing something flat and designing it flat in CAD didn't allow you to see how the product would work until it was printed and formed and assembled. So in response to this, I took the products into CAD again and drew them up 3-dimensionally. So I was able to sort of get an idea of how they would work and how well they would work prior to printing. So here you can see the upper arm design, sort of built-in latches that allow you to sort of adjust the arm circumference, and then the assembled model that you see here. So you can see how the dampeners fix on. they build in an element of adjustability and arm length, although not a great deal. And now I'll go on to sort of the hand support structure. So if you remember back to one of my earlier slides of Tom's arm brace with the blue PLA tray that he rested his hand on, I looked at ways in which you could integrate this into one assembled model. So the tray that he rests his hand on is all part of the same model, which you see here. So it's all one part of the design. It mimics sort of a wrist movement, and it allows the individual to have natural wrist movement without it being so abrupt that they feel unsafe or sort of uneasy about it. The green bits that you see either side of the tray are pretty much mini dampeners, which you can adjust with just the infill density used when printing them. And obviously the guard sort of protects the individual's knuckles and whatnot. An element of Tom's arm brace that was sort of an ongoing thing that he wanted to create was a method of releasing him from the bike. So obviously if you're cycling downhill at high speeds and you crash, your arm firmly attached to the bike isn't really something that's going to be in your favour. So myself, Dominic Egbeer and Tom Wheeler started bringing ideas together on how this could be achieved. We looked at breakaway systems and ways in which a sleeve that slotted over the handlebars could enable this quick release system to happen. So here you see one of the initial quick release systems that we designed. The black sleeve clamps firmly onto the handlebars, and the green bit, which you can see a cross section here, allows restricted up and down movement when going from seated to standing on the bike. So it prevents wear and tear on the handlebars. The ball joint is attached to the underside of the tray that he rests his hand on, and a linear pin that is attached to his unaffected arm means that in the event of a crash, his arm comes off, pulls the pin out, and his arm is hopefully safely released from the bike. So here you can see Tom with the final arm brace on, which I have here. So just to explain a little bit better, you've got the dampeners, you've got the quick release system there, which can be clamped on just using a seat clamp, and then a method of adjustment with BOA. Thank you for listening. I'd just like to end on a short video of the arm brace in use. So this was Tom prior to his accident. Prior to having the arm brace, so he was expected to cycle single-handedly. So this will sort of give you a run-through of how the setup works and how it all comes together. So simple adjustment that enables him to put on the arm brace and adjust it single-handedly. We've been looking into new ways since the linear spring, into looking into ways in which this could be released more effectively and more reliably. That's right. You can see how it could potentially improve balance and sort of the long-term effects that could be caused by not having bilateral arm use. You're sort of overcompensating all the time, and as a keen cyclist that cycles, most days, it's not really something that. Thank you very much.